So, shall we start, sir? I mean, there are 13, 12 people, 13 people right now.
Yeah, sure. Normally whatever you do, I mean, I'm okay with that.
Okay, so hello everyone. Professor Tendulkar is here, Ashish sir is here today, as we were telling yesterday. So, Professor will maybe address you, and you can discuss with sir also if you have any questions. So I think Mahim was asking some questions and telling about his doubts and about the time which is required for coding on the
Yes. Hello, Ashish. This is Mahim.
Hi, Mahim.
I'm a working professional. I'm working with a bank.
Okay.
Yes, the course material and the videos are really you can follow them and you can understand them easily. But while practicing, it takes a lot of time. So whatever programming I have learned is during this IIT Madras course. I have no programming background.
Okay.
I did my MBA and I'm doing banking since last 17 years.
Sure.
The major issue when it comes is to learn all the which SKLearn pre-processing has this, or SKLearn feature selection has these methods or APIs. This is taking a lot of time, and sometimes what for example, in last week 2 session, you have shown one add dummy feature.
Right.
But in week 2 and week 1, we have done similar exercise, but by a different method.
Correct.
So what I found in what we did in week 2, it was much simpler. Adding a dummy, so dummy 1 will come automatically.
Correct.
And that process was a little bit lengthier. So how to deal with this?
Sure. So thanks, Mahim. This is a great question. So there are two courses that we are talking about. One is MLT and MLP. So just to reiterate the philosophy, in MLT, we are trying to do everything from scratch using basic Python libraries. And in MLP is what we are trying to use SKLearn as a library of choice. So when you actually work with machine learning algorithms in your real world, in your real life, you might be using SKLearn a lot because that is a library of choice and we'll be using functions from that. But in MLT, I thought it might be useful also for you to understand how things are designed from scratch, grounds up, right? So that was the philosophy. Now coming back to the question about there are a lot of functionalities and libraries that come to you, and many of you are feeling overwhelmed, which is kind of natural, and it happens when you are learning a new library, right? So what I would suggest is you can go through SKLearn user guide, which we are following extensively for creating our material, and you can just follow our course. And I would suggest do not worry about remembering a lot of different syntax or a lot of different methods. So what is important is to have some kind of a mental map about what are typical steps in doing, let's say, machine learning. For example, we are talking about pre-processing, right? So in pre-processing, what are typical steps? Maybe we have to add a dummy feature, we have to do maybe feature scaling, or it could be standardization. So if you know what are different things that you need to do, generally, there are SKLearn libraries kind of very well designed. And SKLearn has pre-processing module. And if you go to pre-processing module, you will find most of the functions that are of your use. So, when I teach these things, right, I have taken an approach deliberately to give a big picture in the first week. So first week was a bit heavy with terminologies and a lot of new things that are coming to your way. But first week is something I'm expecting all of you to use it as a reference material, and you might have to go back and visit week 1 again and again, just to get a big picture. And do not worry too much about if you're not remembering a lot of APIs and a lot of syntax of the library, I would suggest keep practicing, and with practice things will become better. Because yeah, it is very hard to remember all of these things in first go. I mean, it also happens with me. I do not remember everything, even now. So what happens is that I know that I need to do pre-processing, and if I want to do standardization, I will find that in pre-processing, for example, right? And then in pre-processing, I go and figure out what is the standardization thing. And there are so most of these methods have some very kind of basic syntax, where you can see that for pre-processing we have to supply feature matrix, right? And another thing that you have to get used to is vectorized operations and matrix operations, because that's how most of the machine learning libraries are designed. And as a programmer, we are not used to vectorization or matrix format of the data. So that is another step that you need to take, which is slightly different from the traditional programming, where we are used to processing numbers or arrays or whatever, right? So I don't know whether I answered your question.
Yeah. Hey, Ashish, so one thing is, I think you are rightly said practice. Let's see. I will try to put these APIs on some data set and try to do this. One more small question. So this is just you have shared. There are two methods of feature selection. One is filter based, and another one was wrapper based.
Wrapper based, yes.
So is there any reason why it is known as wrapper based? So
yeah.
Filter based was clear, but wrapper based, why we are calling it as a wrapper based?
Yeah, the reason is that we are using some kind of machine learning. We are using SKLearn estimators for wrapper based, right? I mean, we are making use of some classifier or some regressor, and we have not yet studied that in the course, but it will come eventually. So what happens is that instead of just using some filter, right? I mean, we are essentially using we are using estimator. We are basically training the model, and then what we are doing is we are selecting important features from the model, whatever model training gives us, right? So we are not using any other filter, right? So that is wrapper based is more like pretty data driven. Yeah.
Okay. Thank you, Ashish.
Yeah. I would suggest that you should practice, and do not worry. I mean, the data preprocessing will be a recurring theme. It will come in every week. So even if so I would suggest. I mean, unfortunately, we just have 1 week, and in 12 weeks we are going to finish the course. So try to just focus on important aspect, and even if you do not remember everything, at least remember the key take-home message. From week 2, key take-home message is that we need to do pre-processing on the data, and what all functionality is available in SKLearn. Even if you are aware of that functionality, I think I would say that is a good first step. And then, of course, with practice, you will become more and more. You will become better. Yeah. Thanks.
Thank you, Ashish.
Thank you.
Sir, we have two more students who want to ask questions.
Sure, no problem.
Shreya here.
Yeah, hi, I'm here. Yeah, hi.
Hi,
Good morning, sir. Good morning, everyone. It's a great pleasure to get this opportunity to interact with you. So my experience is also quite similar, because I'm also very new to computer science and programming. So yeah, I have a similar experience with a lot of terms and a lot of new things. A few things I wanted to, kind of get a clarity on. Coming from the machine learning foundations course, right? Machine learning techniques and machine learning practices are quite different. They're heavily implementation based. After 2 weeks, that's what I observed. So my question is, do you think getting a mathematical understanding of some of these things will help in better implementation? Or is it that we just need to focus on the implementation and don't go too much in depth into the mathematics of it?
Yeah, that's again a great question. And I have actually made the course quite implementation heavy, but it doesn't mean that maths is not important for machine learning. So in my teaching experience, what I observed is that most of the students who come from computer science background, they generally, I mean, it is again my own personal experience also. I came from computer science background, and when I took machine learning for the first time, I actually found it very hard to understand how to implement these things in using programming. And when that happens, right, I mean, most of us lose interest and we start feeling that things are quite difficult, right? So so after so many years of teaching, what I figured out is that if you teach students, so my philosophy about any machine learning concept is, I mean, should be taught in three ways, right? Or there should be three different steps to teach a machine learning concept. The first is intuition, right? What is intuition about a concept? Second is converting that intuition into mathematical notations, right? And that's where your maths knowledge will be useful. And the third thing is once you have mathematical understanding of it, then you try to implement that, right? So machine learning techniques, right, should be viewed at every concept. We have tried to actually do it in three different steps. One is intuition, second is the mathematical notation, and third is the implementation aspect. Yeah, but implementation aspect is also an important thing, because if you want to build real life models, implementation is something which is very, very important. But at the same time, maths is also very, very important. And maths in machine learning, actually maths comes in while defining a model, and then maybe optimizing the model using objective functions, right? I mean, using optimization procedures. So, you will require more and more maths if you are coming up with a new machine learning algorithm, for example, right? If you are proposing a new loss function, correct? Or you're proposing a new model, or you're proposing a brand new way of doing faster optimization, right? That's where deeper understanding of mathematics will be really, really useful, right? But as such, if you want to practice machine learning, um, having basic understanding of maths, whatever you have studied so far, will be good enough. Is what is my observation. Yeah.
Okay, sure. So on that, maybe I'll just bring up a specific example, where I
Sure.
felt it was required. So we are talking about filter-based feature selection methods, right?
Correct.
So one
Correct.
of them was the chi-square.
Correct.
I mean, one of the scoring methods is chi-square. So when I read up about it a little further, what I understood is that chi-square kind of signifies the relationship between the features and the labels, and then extracts those which have the strongest relationship.
Correct. Correct.
So, a request is if some tutorials or something can be included for the important functions, right? Which explains what exactly a chi-square does. Like I know, like a lot of selection or a lot of these pre-processing models were explained with examples, and those were really good. But the others, I'm not sure, like if the details are not there because they're not important, or is that something that can be covered in a little more detail with the intuition and the math is a request.
I see. So there are a few challenges in doing this. So what I assumed is that because you have done some of the mathematics and statistics course, students have background in this, which is what I assumed while teaching some of these things. So that's why we did not get into details of mathematics of some of these things. But if that is not the case, then maybe there could be, we can think about arranging some of the tutorials or whatever. Right? So
Yes,
it will
sir,
be great. Yeah, it will be great if you can actually put in the forum, right, every week.
Sure.
What are the topics where you are facing difficulty, so that some help can be arranged in that week.
Sure.
Because,
so that would be great. Yeah.
Yeah, because we are also doing this for the first time, and this is a first offering, and we are also learning about what works and what doesn't work. So your feedback is critical, and I appreciate that. Yeah.
Sure. Sir. Thank you so
And
much.
other thing that I would like to say here very briefly, I don't want to hold DJ from conducting the session,
No, sir.
is that, so there are things, right? I mean, some people generally think that they'll first read a lot of maths textbooks, optimization textbooks, and then they'll come to machine learning. That is also one school of thought among many machine learning aspirants. But that kind of doesn't work that well, because there is just too much of background information that you need to read. So that's why we have taken a middle path where we are laying down a framework. We have a very nice framework in machine learning techniques where we are talking about every machine learning algorithm with 5 components, and that kind of componentized framework helps us to make progress, right? And at the same time, you can keep reading a lot of other background material about various mathematical concepts and things like that. So that will definitely better your understanding. So any more efforts that you put in will definitely fetch in more returns. Yeah, thanks.
Sure. So just one last request probably is, I think week 1 did cover a lot of things, like overview on a lot of things. It'll be good, like if certain things, an overview is being provided, right? If it's going to be covered in more detail later, I think many places you have mentioned that, but everywhere where it's going to be covered in more detail later, if that can be mentioned, then that way there's no
Sure.
confusion as to what we
Sure.
need to study and what we can leave for later.
Sure, sounds good. So week 1, right, MLT, right, you
Yeah.
will see that every week you will see reinforcement of each of those concepts that we discussed in first week.
Yeah.
So if you have any issues with that, I mean, just bring it up in one of these live sessions. I'll be there in every live session for 10-15 minutes for interaction. Yeah.
Sure, sir. Thank you so much. And I think the whole structuring has been done very nicely, like SKLearn introduction and whatever I've understood so far, it's been put across very nicely. So thank you for that.
Thank you for the feedback and kind words. Okay, I'll probably take one more question and then I'll again be present in MLT. So if there is a quick question for a couple of minutes, I can engage. Otherwise, I'll give it to DJ.
Sure, sir. I have 3 people who are asking our first question. So, Rajiv Banerjee.
Yeah, good morning, sir.
Good morning.
I had couple of questions actually. Say for example, when we use a function transformer, okay. So that time we pass a function, and you told you can generally you can pass a logarithm or some square root. Okay. Now in that case, like when we use log and square root, it will short the range. Like if the range of that feature is very high, we can short up that range, right?
Correct.
So point is, say for example, after function transformer, can we also after that can we apply like standard scalar or something that sort of, or we don't?
That is no, that is okay. You can apply standard scalar after transformation. That is not a problem. Yeah.
Okay,
sometimes,
but
yeah.
Generally, like after function transformer, then is there anything anything in that pipeline after function transformer?
So see, I mean, data preprocessing, I mean, machine learning, there are a lot of things that are customizable, right? And there is not a single right thing. So you can try adding other feature transformer after. So you can have a series of transforms, right? You can do function transformer, then you can apply standard scalar on it. That is all of that is fine. And it really changes from problem to problem. So there is not a single correct answer to this particular question. Is that clear? So normally, for example, when we do, let's say, polynomial transformation, let's say we do a square of a particular feature, then obviously the range is like range gets short up, right? Then we apply standard scalar on that just to get all the features on the same scale. And scaling is all the more scaling becomes very critical if you are using a method like stochastic gradient descent or gradient descent. So scaling, so some optimization algorithms are very, very sensitive to scaling. Yeah.
So then in wrapper based method, we generally pass a estimator object, right?
Correct.
Now basically when you do that fit, that time that estimator objects get trained, right?
Yeah, estimator object gets trained, yes.
So exactly. It is kind of like you write a estimator first and then do the transform. It is equivalent to your wrapper, right?
Yeah. So wrapper, what we do is we use estimator object and we train the estimator object and find out the important features from the estimator object. So that is the high level thing of the wrapper. Now, how do you gauge the estimate? Importance of the feature changes from one method to the other. So that is quite method specific. Yeah.
Okay. So then in like earlier course like MLF, we studied one thing called projected gradient descent, like that is on constant optimization.
I see.
Okay. So here we have implemented the gradient descent in MLT.
Right.
But the question is like that MLT can be tweaked to provide some constraint as well, like in the
yeah. So you will see that there will be constraints that will be adding. So that those constraints are called as regularization. They will be coming very soon, and we add certain regularization which are we are trying to constrain the weights of the features. So in that case also we can use gradient descent.
Okay. And other than that, like any specific constant, say for example, my x cannot take like values from between this and this, right? Can I
So
use that kind of a constant as well in that model?
not really x, because we are not trying to optimize on x, right? We are just trying to optimize the weight vector, correct? We are trying to get the weight vector that optimizes the loss function. So x is fixed. So there is x is
Sorry,
not
x is
involved in
fixed.
x is fixed. X, there is no it is not involved in it doesn't change in optimization. So only thing that changes during optimization is the weight vector.
W.
So
Okay.
we put a lot of constraints on weight vector, and there are ways in which you can do it.
Understand. So, sir, the last question is on that visualization stuff. Like in your week 2, say for example your PC and all, right? Like those visualization, like will you be covering in some like later session about those visualization aspect, or like it will be whatever is in week 2, week 3, like whatever is coming from that?
Yeah, we are not covering visualization again, but we'll be
Okay.
using some of these visualizations going forward. Right, and visualization is again a very, very deep topic, and unfortunately, we do not have enough time in this course to
Okay.
cover because visualization is not a main topic of this. But visualization, I would encourage, if you're interested. There are a lot of other rich visualizations that are available, and of course, you can study those things outside this particular course. But we have covered. I mean, having said that, we have covered visualizations that are important from machine learning perspective, right? So whatever visualizations that are required for data exploration, most of the important visualizations have been covered. So whatever is covered is also good enough for you to get started with.
Okay, and also like say for example the Cola file, like you go through in that video, right? If you can also like for some time like there are something written so code, right?
Right.
If you can expand that so that we can stop the lecture there and see like how
I
the
see.
code has been.
Sure, that can be done. Actually.
Yeah, because like that PCA stuff, like when you are plotting those principal axes, right?
Right. That
And
is
then
done. The code is
that C3 vector, I
yeah.
couldn't plot that.
Okay.
It's
Sure.
been quite.
I'll do that. I'll keep this in mind, and I'll click on show code, and so that you can have a glimpse of the code. Okay.
Easy. Okay, sir. Thank you.
Thank you, DJ. So, anyone
Thank you,
else?
sir. Yes, sir. One person is there if you have time.
Yeah, I can take. I can take it, but is it okay for you?
Yeah, sure, sir. No job. Yes, sir.
Okay.
Anand Kumar is here. Mr. Anand Kumar.
Hello.
Yeah.
Hello, Anand.
Sir, good morning.
Hello. Good morning. How are you?
Yeah, I'm very fine, sir. Thank you. Sir, first of all, I like the approach in which we don't focus too much on the mathematical details first. Rather, we try to go hands-on and then go backwards working from it. I like that approach really much. I think it is much more efficient, because focusing too much on mathematics and programming sometimes burns us out.
Right.
So that I really like to thank you about. That is a very good approach. I had one question, sir. Especially in MLP, since the initial 6, 7, 8 lectures, they are regarding the theoretical part, and then there are hands-on demonstration. In the first 7, 8 lectures, I was not really sure about what the course is expecting me to do. I mean, there were so many terminologies introduced, so many transforms introduced. Barely I could remember 3 or 4.
Yeah.
I was just hoping that you may guide me. How should I approach this? I mean,
so are you talking about first 6 weeks, or are you talking about first week itself?
Second week, sir. Second week, initially 7 or 8 lectures, they are completely.
Yeah. So see, the idea is that the data preprocessing is a huge topic, and there are so many data preprocessing techniques that are available. So the purpose of the week 2 is to make you aware or give a big picture about what are different things that are available. I don't expect you to remember each one of them, but at least you should have a mental map about what are different options that are available to you, right? And these things will be used again and again going forward in the remaining in the subsequent weeks, right? So we might be making use of standard scalar many times. There could be things like feature selection that might come again and again. right? So there are some of these things that will be repeated. So you will have a chance to recall these things and remember them once you practice more and more. Yeah.
Okay. So one more suggestion I had regarding that collab notebook. I mean, one clarification was given that since the graded assignments are very much similar to
Yeah.
what is being shown in the collab notebook, so course team would not like to share that collab document with us. But when the graded assignments deadlines are over, because that collab is so well documented, it is like a revision notebook for me.
Yeah,
Whenever
totally.
yes, it will be a very good revision notebook, a very good reference material for us. So if it is possible, after the graded assignments are over for the particular weeks, if then the notebooks can be released, or if that cannot be done, then at least a PDF of it will be released.
We'll think about your suggestion. Okay.
Okay. Thank you, sir.
Sure. Thank you. DJ.
Yes,
So
sir.
maybe last couple of minutes, and maybe one more question I'll take, and then we can continue in the MLT. I'll again be presenting.
So one person is there, Trivikram only. He has one question.
Sure, no problem.
Good morning, sir.
Good morning.
Good morning.
Hi, Trivikram.
Hello, sir. How are you doing?
I'm good. How are you?
Good too, sir. Good too.
Yeah.
Sir, I just want your so lots of people have asked this question before, but I would just like a clarification and a suggestion from your end. How do you suggest all the students approach this subject? Some tips, some ideas, or so what we were doing in a subject called as data structures, we were coding alongside sir in the lecture. So would that approach be very beneficial for us? Should we be expected to do some exploratory analysis by Googling things out, searching few things on Gaggle, and on at what degree are we expected to do that? That would also be very much beneficial for us, sir.
Sure, that's a great question. Thank you for asking. So, I have tried to actually cover the material such that you don't have to do a lot of exploration outside what we are covering, especially in the initial weeks, right? So basically, what is the objective? What is the ultimate objective for us, right? Ultimate objective is if you can go out and start coding machine learning algorithms for solving specific problems, that would be a very good outcome of the course, right? So in the initial weeks, we are trying to prepare you with different toolkits, with different tools. And I would expect maybe not in the course, but after the course, all of you should start participating in Kaggle competition, where you can actually use some of the fundamentals that we have studied in the course and apply them in the competition. And of course, competition has some more tricks that you will learn as you move forward. But I would not suggest you to do that while you are in the course, because if you start doing it, you will spread yourself too thin, because the course material also needs a lot of work from your side. So one thing that I may suggest, right? I mean, if we can actually replicate the collab notebooks that we have, that would be a very good exercise for all of you.
Okay, so
because
with you.
Yeah, you can do it alongside with me, or you can just in MLT, let's say you say that I want to code linear regression from scratch.
Yes,
now,
sir.
Can I do it? So don't first go through the video, understand it, and then don't look at it and try to produce it yourself, both in MLP and MLT, right?
Okay.
When you do that, you become better at it, right? Easiest thing is to copy the code, right? But
Yes,
that's not good. That's not going to help anyone.
absolutely.
Because copying the code, you might get a feeling that I have executed the code, but executing code itself is not good enough, because that gives you some false notion of security that you know about it, but it is not enough. When you start coding, you start understanding what are the nitty-gritty details, and you will fail. Your code will not work in certain cases, and that's where you gain valuable experience. And there is no substitute for experience, your own experience, right? No amount of teaching or no amount of mentoring will get you there. So I suggest try to reproduce the collab notebooks yourself. That would be really awesome. And our Solve with Instructor sessions have also been very carefully designed to reinforce some of the concepts. So when you're there in this session, also try to code alongside the instructors. That would be nice.
Absolutely. Okay. And sir, let's say I come across a function that you have taught, and you just touched upon it. I mean, it's nothing against it, but I understand there's a lot of stuff to cover. But you touched upon it, and I haven't really understood what is happening in the function. So I decided to go to Google and find out certain things about it. At what degree am I supposed to research upon the function? That's my last question.
Sure. So whatever is important, I have tried to give enough time in the course for whatever is important, and whatever is not important or whatever you can just use it as it is. We have not spent a lot of time on that. So if you focus on whatever material that we are covering, and if you have doubts in that, then it makes sense to seek more material. But if something which is just mentioned in passing, most probably it is not relevant for that topic, or that might have been covered before in the course, or or it may be something that you may have to pick up on your own. So there could be 3 different categories, right? So certain things like visualization and other things, I mean, I have not really spent a lot of time explaining how I'm visualizing things, because that was not the main topic. But let's say I'm actually teaching you how to use SKLearn API for regression. Then I have spent actually enough time. You will see that in the subsequent week that we have spent enough time explaining the parameters of the functions and things like that. But beyond that, if you need help, you can reach out to us or seek material from other resources.
Absolutely.
Does that make sense?
Yes, I have understood very well. Basically, the gist is that to focus on whatever you have focused upon and code alongside you, and practice as many problems as possible, as possible, and we'll get a good hand on it.
Yeah. So hands-on is very important. And again, at the same time, as Shreya was pointing out, right, maths is also important. I don't want to say that maths is not important. But the way I have structured the course is not to scare away people with heavy mathematical notations. Because some of the machine learning courses, they are pretty heavy with math notation and other things, and that turns down a lot of people. So we have tried not to do that. But maths is inevitable. I mean, you will see a lot of equations coming in the subsequent weeks, but we have tried to explain things as much in as much detail and in as simple terms as possible. So, all right.
Yes, sir. Thank you very much, sir. It was a great chance, sir, to interact with you. Thank you very much.
No problem. Thank you. Okay, DJ, is there anything else, or should we move
on? So right now, nobody else has raised their hand, so maybe we can continue the discussion with you in the MLT session. I think Swarnim will be handling the MLT session, so
no problem. Thank you. So I will hang up. Okay. And,
Sir, can I ask one more question?
I have to take permission from DJ because he
sure, sir. Obviously, please go ahead.
Okay, no problem. So, but keep it quick, okay? Keep it quick,
yes.
So that
Sir, like coding function, like whenever we are selecting the features, right? Mutual information and your chi-square, right? Mostly, like both of them, like take care about the variance of the feature, right? Like depends upon the variance of the feature, they select the best features, like whatever has maximum variance. Now, is there any?
Go ahead.
Yeah, is there any other criteria for a good feature other than variance?
That's a good question. So variance basically helps us to check if feature has enough diversity in it, right? If the feature has the same value, then probability is not that useful, right? I guess there are no other good measures that comes to my mind right now. But mutual information actually looks at the feature and the label at the same time. So you have to always look at the feature in the context of the label, right? You have to look at these two things jointly in most cases to judge whether the feature is important or not.
So, sir, another thing like that comes I've did a little bit search in Google, and I found, like, say for example, like if there is a continuous data and if we can bin that, okay. Now after binning, like say for example, I take a midpoint and calculate the entropy of that data. Is it also a kind of variance of essentially a variance in that feature, or?
Entropy can tell you, whether there is enough variance in the data or enough variability in the data, right? Because
again, same thing, right?
Yeah. Again, the same thing. So, so most of these things are related. in some sense, right?
Yes.
Yeah.
Okay, sir. Thank you, sir.
No problem. Thank you. All right. So continue and have fun with Solve with Instructor with DJ. And I'll see you later. Thank you.
Thank you,
Bye.
sir. Thank you very much.
Bye.
Okay, so we will proceed with the questions. First, yeah, we'll straight away dive into the questions. I'll present the question and then we can discuss. So the first question is a simple imputer one. Let us start with it. So just raise, yeah, I think it is visible. Is it visible? My screen is visible.
Yes, sir.
Yes, sir.
Yeah, sure. Please, yeah, you can start. Try to start coding in your Colab, and then if once you finish your coding, just let me know by raising the hand or in the comment section. Okay. So once sufficient people have done, we will show the decision, show the solution, etc. Okay. So I will read the question maybe. So the first task is to import simple imputer from SKLearn, as we know. Then we have one matrix. So you are taking a matrix 7 with 3 columns and 1, 2, 3, 4 rows. Okay, 753 is the first element. Then 1622. Then 3193. So in the first row there are no not available elements. Then the second row first column and the second row second column elements are NaND, so they are not available. Then 1966 is a third column element. Third row has 1205 and then NaND value again, which is not available data. Then 981 NP NaND, that is again NaND value, and 9211. So we have to impute the missing values in the matrix using the simple imputer with mean and median. Sorry. So you have to print the just a minute. So you have to print the imputed matrix using fit transform and see whether just change the imputation method from mean to median and just check whether there is any difference in the matrix, imputed matrix which has come. So just to remind you what is imputed matrix, let me stop sharing this part once more. Now 1 minute, and then you can just a minute. Yeah, so we have what is data imputation. You remember that there are many ML algorithms which need full feature matrix and they may not work in presence of missing data. So what data imputation does is that it identifies the missing values and replaces them with an appropriate value based on the fixed strategy, either mean, median, or mode. So what SKLearn does is SKLearn provides the sklearn.impute.simpleimputer class for this purpose. So first you should import it from sklearn.impute import simple imputer, and there you can use two strategies, 2-3 strategies. So the missing values can be integer, float, or string, NaN or none value. So the default is NP NaN. So basically the NP NaN values will be replaced with what? Now either mean, that is the missing values will be replaced using the mean, or the median, then most frequent value, or the some constant value. Okay. So mean and mode obviously works with the numeric data, and most frequent and constant, these two can be used when there are string data or numeric data as well. So with that, we will go to the question, And so remember that first step is obviously to import the SKLearn.impute from from SKLearn.impute you import simple imputer. Okay. So let me show the question once more. So this is our question. So let me know if you have any doubt in the question, and we can discuss that. And once you finish your questions, finish answering, let me know in the chat window or raise your hand, and we will show the solution.
Visible.
Sorry?
Now it's visible.
Okay, let me know if you can't view the slides. Okay, if there's a problem.
Sir, when we are using imputer, we have to mention the missing values, right?
Yeah, yeah. So you have to show the first you have to put this matrix, then apply simple imputer on this matrix with the, so then what the simple imputer will do is it will fill the matrix values, the not available values, with either the mean of the columns or the median of the columns. Okay, and then you will print the final matrix using fit transform. Okay. Thank you, Tanvir. So I have seen that Tanvir has finished it. Tanvir, let's wait for some more people to finish, and then we will go to the next question. Rajiv also has finished it. Great. Kish also finished it. With Kumar Trivikram. Okay, let's wait for 2-3 minutes and then.
Hello, sir.
Yeah.
Sir, I have a question regarding this computer class. So right now, when we are trying to impute using mean, let's say np.nan in the second array, the first np.nan, that's basically going to be a mean of 753, 1200 and 981, correct?
Yeah.
So is there a method in which we can impute the values, let's say the third array out here, 1 2 0 0 5 and np.nan? Is there a method in which we can find the mean of 1 2 0 0 and 5, like the array itself? Here we are doing it vertically. Is there a way we can
So
do
you
it?
can we can just transpose it. No?
Okay. Yeah, I thought about that. So there is
In the axis 0 to 1, it will work. You have to put the axis 1 or 0.
okay. Got it.
Okay, so yeah, obviously it's, I think many people have done. Yeah, we will go to the next question. Just a moment. Yeah, so this was the question: import simple imputer, then take a matrix. So firstly, we do all the importing of the usual libraries. Okay, so we have import numpy as np, matplotlib, and this is not required as of now, but yeah, just at the beginning, doing everything. Okay, finishing. So obviously from SKLearn.impute, import simple imputer, then import numpy. So and now we are defining the variable int mean equals to simple imputer. Sorry, we are defining. Then missing values equals to np.nan, and we are that is what we know, right? That we will be we will be replacing the np.nan values, and the strategy that we are using is mean, right? So now what we are doing is we will be we are generating a new variable which is x equals to imp this variable imp mean or imp underscore mean dot fit transform. Okay, so this is the way to apply fit transform, imp underscore mean dot fit transform. Then we write the whatever matrix is given to you. So 753, 1622 and everything. And then we can just print the value. So this is the value coming when we are having mean as the strategy, right? So 7.53 and 9.78, etc., whatever. Now what happens when we are putting median as the strategy? So here again, previously it was strategy equals to mean. Now we have put the strategy to be equals to median. Okay. So then what is our values coming? So you can see that 7.53 is first one is okay, second one is also okay, and third one is also okay. The fourth one value, the second row first column value was in mean, it was 9.78, but as we have taken median here, so it has become 9.81. So similarly, the other np.nan values will also change, like the 4.79 value has become 3.19 here, and so on. So that is our first question. Okay. Yeah.
I have a question.
Yeah, sure.
If we don't put missing values mp.nan, so what default it will take? Will
I
it
think
will
the
it work?
default is np.nan only. Let me
Okay.
try.
I think it is np.nan because it's working without missing values also.
Yeah. Sorry, I have not.
Yeah, default is np.nan. It is mentioned in the documentation.
Let us try once. Let me try once. Yeah. Okay. So that also can be done. Okay. If we are not given. Yeah, as someone told. I don't know, sir, what is the mean.
Srinivasan. Yeah.
Srinivasan, sir. Yeah, thank you, sir. Yeah. So anyway, I'll go back to the slides because here in Colab it is difficult to. Just a minute. Let me share my screen. Yeah. So we are at the next task. So next task is also very easy. you have to import the function transformer from the SKLearn and then apply log 10 to log base 10 to the elements of the array. So basically you have to do the log of these elements. Okay, 0, 1, 2, 3, 10, 11 and print it. So just see whether you can do. I think it will take hardly 2 minutes or 3 minutes for me. Just 1 minute.
Sir, I'm sorry. Can you please let me know what is the library for SKLearn transformer? Where is the? I mean, which class it is present?
So you have to import SKLearn.preprocessing.
So you are not audible. Sorry.
I'm not audible. Can you hear me now?
Yes, sir, you're audible.
Yes, it's might be my
so you have to import function transformer from SKLearn.preprocessing.
Thank you so much.
So this is throwing an error because of the availability of 0 and log 0.
It's showing an error. Is it showing an error or just giving? I mean, showing a warning or something.
It's giving infinity.
Warning. It's runtime warning.
Yeah, warning.
Giving a warning.
Yes,
Okay,
sir.
so
A warning.
yeah. So has how many people have finished already? 4 people have finished. So like this, small questions only will come, I think, in the quiz. Okay. So although we can say once some deadline, once the papers are already done and approved, but yeah. So this kind of small things will come, like from where, as someone asked, from where the simple imputer is imported, or what will be the output if you this previous imputation question only we just give you, and like how it is done, right? I mean, how the imputation process is done. So you can just impute and click on the correct option, right? Which one is the correct imputed matrix. So things like that, I think, will be coming in the question, in the quiz.
So in the quiz, like, we need to do this calculation manually, right?
You have the calculator there, na?
Yes. We're using that calculator. Right?
Yeah.
Just a curious thing, sir. What does minus infinity? What will it do if we continue to use it further? Will the other methods work with that value?
I'm not sure, sir. I've not tried. We can try maybe.
Because I felt that maybe the predict method might have an issue, right?
I think so. I mean, with minus infinity, yeah, I mean, obviously it will give some issue. Or maybe some garbage data it can give.
No, there is no predict method in function transformer.
After that, you will use the data do other work, right? So that time.
No, sir. Actually, if you go to the documentation, there is just 5-6 methods, and predict doesn't make sense here, sir. This is not a machine learning model, right? This is just a pre-processing step. So,
no, what I meant was, sorry.
No.
Okay, I may be making a mistake. Saying if you take this data and take it to the predict time and all that stuff, so obviously the data has minus infinity. I don't know what the rest of the function.
Oh, right. Oh, yes. In that case, sir, I think it will be. You'll have to specify if to ignore or not. There's something ignore index. I think it's by default, but if np.infinity you specify explicitly, then it will definitely ignore that.
Actually, generally, again, they will put as a imputer as a mean, okay, for the infinitive case, the way we are putting for the mean value, so that it should not go a high value.
Here it was just put, I mean, like, yeah, I mean, whatever you said is true. That's correctly. Here we just put to show, like, you know, we have read in the maths before, then we just checking it. So what is the log of 10 we know, log 10 base 10 we know, what is the log 100 base 10 is 2 that we know. Okay, so just verifying, seeing an example, working example. Okay, so I think many of us have done it already. We'll just show it. Yeah, so this was the function transformer that we are using. So from SKLearn, as many of us have already solved it, from SKLearn.preprocessing, we are importing the function transformer, and then we are putting np.log10, right? So this is one function, log10. So similarly, there are other functions also, like we will go into the collab. Just 1 minute, let me finish the function. So then we are printing the variable x, and then we are feed transforming it, transforming the x to and printing it. So and the before the transformation, it was this one. The only matrix was this one. The given matrix is this one: 0, 1, 2, 3, and 10, 100. And after transform, as someone showed, there is a warning coming, and minus infinity, 0, etc., etc. is coming. So there are other things, other functions like this as well. So transformers are, again, as we were discussing, that it enables the conversion of an existing Python function to assist in data cleaning or whatever. So again, we have imported the function transformer from SKLearn.preprocessing, and there are different transformers. So one is log1p, I think was shown in the np.log1p, which was returning the natural log of the 1 plus the feature value. Okay, and this was shown in the lecture, and as we know, there is the opposite, the component, the complement or the dual of it, which is exponential exp m1m, I think, or exp m1, which actually what it does is that it reduces 1 or subtracts 1 from the feature value and then exponentiates it. Okay, so these kind of functions are always available, which are useful for the mathematical process, and we can use that as per our requirement. So here in the wine quality, we have actually applied it, and wine data quality, we have applied it, and we can see that the values have changed, and maybe that we can see that in the when we are plotting the graphs and etc. Okay.
Sir, I have a doubt in this.
Sure.
Sir has used in parameter called validate is equals to true. What does this parameter do?
Which one? Which one?
Sir, in calling the function transformer as an object here, sir has used validate is equals to true.
Validate equals to true. I'm not sure actually. Can I get back to you on that?
Yes.
I'll just check into it. Let me, yeah, let me get back to you. Does anyone else know? I mean, can discuss also.
Can you repeat
Someone?
the question once?
What does this validate equals to true part, this part do here?
Passing some value, and if it is unable to, you can say convert it. Okay, that time it's throwing error.
I think the, yeah.
What type of value we need to pass? Need to check. Not sure.
Let me check the function transformer SKLearn. So validate equals to false.
Sir, it just checks whether if transformation is possible or not.
Yeah, so it indicates the input X array should be checked before calling the function. So if the validation is false, there is no input validation.
So I think it's,
so for example, in the past question, we had 0, right? So over there, it will raise an error that you are doing something with 0, which is not possible.
So I have to use validate in our example also, but there is no change, like whether it's false or not true, it's not changing anything.
Yeah, can you see here the part which I just now highlighted?
But they said they'll just raise an exception. They won't not run it. They have said they just raise an exception.
So if it is true, then the matrix will be converted to a NumPy array. I mean, the array will be formed, and if it is not possible, then they will raise an exception.
Yes, sir.
And if it is,
I tried it out, and for false, that exception is not coming.
Okay, so what is it giving? It is giving the same value, is it?
Yes, sir. There was something in red highlighted portion that was coming before. That was because by default it's okay. By default, I think it was true. But if you take it as false, validate is equal to false, that red section will not come. Basically, it
throws an error.
Yeah. It was giving a warning, right? That np.log basically log 0 base 10 is infinity. So it was giving a error. You can just run it out, sir.
Actually, when I validated, well, I kept the validate part as false. I didn't get even the exception of I am taking log as 0. I'm using Jupyter.
Sorry,
arrange ಮಾಡಿದ್ರಲ್ಲ ಅದಕ್ಕೆ ಸೆಷನ್ ಅಂತೀನಿ ಕಾಲ್
can you mute yourself? Okay, so validate equals to true is this thing, fine. And what happens for value equals to false? Okay, here also the same thing. Okay, fine. I'll just
rerun it once more. Rerun it once more, please.
Minus infinity is 0.
Okay.
0.30103 47712.
Because in Jupyter, no, I am not getting the error when I'm doing it. I'm putting validate as false.
Here it is.
If you want, I can put it here.
So just one add to that my question. I just want to know, what does input validation mean? What does it actually checks?
Yeah, it is checking whether a matrix can be generated, I think. Okay, if it is true, then the matrix will be converted to a 2D array or sparse matrix. And if the conversion is not possible, then an exception will be raised. Okay, so it indicates whether the input array can be converted to another array. I mean, whether the array or the output matrix can be generated. So I think here it is possible to generate now whatever we put. If it is false, there is no input validation. Okay, so I think if it is false, then it may not check. That may happen. I'm not sure, but one thing I think what is happening is that if it is false, if the validate equals to false, then it will not check whether the thing can be, whether the matrix can be generated. So like suppose here, if we put np.log10, suppose I put true. Let me check. I'm not sure whether this is the answer, but sure. Suppose I have only one value. So fine. So this will throw an error. And if I check false, this is just my guess. Okay, and also it is does not support. Okay, let me get back to you on that. Okay, that will be better. But I think that was what was happening. That I mean that is what the SKLearn module is telling. The manual is telling that it is just checking whether the input array can be converted to a 2D NumPy array or sparse matrix. But I'll get back to you on that. Okay. Can who raised this question? Yeah. Can you just post this in the discourse also? That will be helpful to.
Yes, sir. Yes, sir.
Yeah. Just post this once. Okay. Yeah. Let us get back to the. Okay. So that is the question. The program, guys, currently, and yeah. Okay, so the next task is this one. So read the CSV file from the IDs data basically. So https archive.ics.uci.edu. Define the column headers as a sepal length, sepal width, petal length, petal width, and label. So generate a kernel density estimation plot, a box plot, a Valin plot, and a correlation between each of the features, each pair of the features. Then you have to generate a new feature matrix consisting of all the polynomial combinations of the features with say a degree 2. So if an input sample is 2D and you have the form A and B, these are the two variables. So these are the two features. Then what are the polynomial features that can be generated? 2 degree features. So there can be 1 because A to the power 0, B to the power 0. That is 1. Then A, B, A square, A into B, and B square. And you can print the shapes of the feature matrix before and after the polynomial transformation. So this is our task. First thing will be to import the, obviously the import the IRIS dataset.
Sir, can you paste the URL in the chat window?
Yeah, sure.
You cannot copy it. That is the problem.
That is also a problem. Yeah.
I can still put it.
Okay, we can click and then we can copy it.
Oh, sorry.
So can't we use the iris dataset present?
Yeah.
That will be busy. Yeah, we can use that one.
Yeah. If you're using your Colab, then fine. Still, I'm giving you the link here. Okay. Just, I think we are also. Okay, I have the.
Sir, one major question, sir. Do we have to define the calls here? I know this instructor also used this, but do you need to define these calls? Can't we just do it without defining the columns?
I think it can be done. Have you checked it? I mean, without defining the columns, we can do one thing. We can do one thing. So once this is done, we can check without the columns line. Okay. So let me know once you are finished. So let me know, and I'll give you the slides. I'll just arrange some other material. Who was asking me about the calls thing, sir? Hello? Someone was asking me about the columns thing. Is it Mr. Srinivasan or someone else was asking about the columns thing? So what is happening is when you are plotting the data, the KB or the violin plot or the box plot, if you don't put the columns, then what is happening is that the legends will not form properly. Okay, so it will make a row 1, row 2, row 3 kind of thing. But if you are plotting the columns data, then it will give the density plot according to that. So that is the only thing which is happening.
Sir, this correlation plot is that heat map. Sir?
Sorry, I was on mute. So it was not a heat map. It is basically the bunch of scattered. Okay.
A scattered plot.
Yeah.
Okay.
So basically, you do a scattered plot between sepal length. I mean all the 4 variables: sepal length, sepal width, petal length, petal width, with all, so 4 cross 4 basically. 16 curves.
Like we can use that scatter matrix.
Yeah. So basically scatter. So what is the after polynomial transformation? What is the number of sorry? Is there any noise coming from my end? I mean, some background noise is coming. Some
Yes, sir, a
construction
little bit.
Okay, sure. I'll Yeah, sorry about that. I mean, IT is going through a lot of constructions recently. Rajiv, can you check the data once? Because for
Yeah,
our case, it is.
So like degree 2, right?
Yeah, degree 2. So there were 5 features, I think.
4.
Right? I mean,
4. Sepal length, sepal width, petal length, petal width.
And there is one label features also, right?
Like I removed that label actually.
Yeah, but then the number of features also will be removed. But anyway, so for 4 features, how come 45 is coming?
See my x dot shape. Okay. No. Like.
Yeah, just check once.
Yeah. X Y. Yeah, it's 15.
Yes.
So we have to make the plots with all these
sepal length,
headers.
sepal width, but petal length, petal.
I'm a bit confused. Okay, so we have to like sepal length and sepal width के 2 graph बनाने का and उसके लिए petal length and petal width के लिए 1 more, right?
नहीं आपका मतलब ठीक है, हम लोग शेयर करते हैं.
Okay.
Let's see the solution also. Just a minute. तो बेसिकली क्या कर रहे हैं कि we have this thing CSV file. First we have to read, then these are the column headers given to us: sepal length, sepal width, petal length, petal width, and label. Then we are generating some 3 plots, and we are generating the correlation plot between the pairs. So and then the other things come that represent efficiencies, etc. So the first part is column that that is what we have defined, that these are our column headers, and sepal length, sepal width, or whatever. Then what is it? We are defining one variable a, and inside a we are putting the data file with the column names as the previous calls, right? So if we are not giving that, as I was telling, so basically what will happen is when we are generating this this graph, the legends will come 1, 2, 3, 4 like that. Okay, this thing will not come. The sepal length, sepal width, etc., will not come. So anyway, this is our, we are defining one variable ax equals to a dot plot dot kde. So that is our dot plot dot kde is our code for generating the kde plot. Okay, so that is done. Then we are generating a box plot. So how are we generating the box plot? So this is our, so you can orient it horizontally, or I think vertically also is possible. So if this is done, let us see. And so you have sepal length. So one column, one box plot for sepal length, one box plot for sepal width, and petal length, petal width. So how do you do that? We have the data set here, A equals to this full data set. And then what we do is we use the seaborn. Seaborn we have already imported, right, at the beginning. Yeah, import seaborn as SNS. So again, what we do is we put SNS dot box plot. So what is our data? Data is A. A is what? The iris data set, right? And we can orient it horizontally and give the different color shades. Okay. So like you can obviously, someone was talking about visualization, so you can put maybe vertical, and let us see what happens. Yeah, so it will give a vertical box plot. Okay. Or if you put some other color shades, maybe I think some other color shades also will come. Like that, we can do different things. Okay. So we will get different sepal for sepal length. We will get one box for sepal width, one box for petal length, one box for petal width. Similarly, we have one box plot, so we have Hyaline plot also. Here also, AY equals to the seaborn Hyaline plot. Data is our data set A. Orientation is again horizontal and a Hyaline. So our palette again we took set 1. And so this is our Hyaline plot. So for sepal length, one Hyaline plot. For sepal width, one Hyaline plot. Petal length and petal width as well. So you can again you can do the same thing here also. You can put the vertical orientation of the plot, and similar things will come. So these were our columns: sepal length, sepal width, petal length, petal width, and label. So 5 columns, and after polynomial transformation, I think Rajiv has said in the chat window surely that there are 15 features coming after transformation. So at first there were 4, I guess, obviously, sepal length, sepal width, petal length, petal width. And so if we put that, so one will be one feature will be 1. So A and A, B, C, D, these are the 4 features were there. And so 1, A, B, C, D, A square, B square, C square, and D square. Then A, B, B, C, multiplication of the first 2 features, multiplication of second and third features, then CD, which is the multiplication of the third and fourth features, multiplication of the first and third, second and fourth, and then first and fourth. So these are the possible combinations which we are getting. For this, how do we do? So basically, we were asked to do what? We had to generate a new feature matrix of all possible combinations of the features with degree 2, and print the shapes of the feature matrix before and after the polynomial transformation. So if we have a 2D matrix of the form A comma B, then the degree 2 polynomial features are what? Now 1, A, B, A square, AB, and B square. Right. So similarly, what we did is we imported polynomial features from again SKLearn.preprocessing, and we print the shape of the matrix. So at first it was 150 and 5. Then what happened is we are applying the polynomial features directly. So we are importing and applying it inside the variable poly, and the degree is equals to the second degree, that is 2. And so we are putting up to the 4th column of A, and we are fitting it up to the 4th column. So what is happening is that we are getting the data set after a data shape of the data after applying fit transform. So what happens? Suppose we are putting 3rd degree. So 3rd degree also, I think obviously the range it should increase. I think the number of features. Let us see. Yeah, so previously it was 15, now it has become 35. So things like that it can be done. Okay. Or if we take up to 5th column, I'm not sure. Let me check. But okay, so the label, yeah. So this is a string column. So therefore, it could not be converted to float. Okay. So if we give up to 4,
sir, can you please explain the fit transform? The argument given in the fit transform function.
So we are applying inside the poly variable. We are just directly applying the polynomial features. Okay, polynomial features which we have imported from SKLearn.preprocessing. And then this is our second degree polynomial which we are applying. Now, again in the iris data polynomial, which we have again defined another variable, there we are applying the fit transform in the A dataset. A dataset is our original iris dataset. Inside that, up to where? Now up to the 4th column, right? That is the 4th column was our sepal length, sepal width, petal length, petal width, and up to that. So 4 columns, and up to 4 columns, those 4 columns we are applying, and so applying the this polynomial transformation, right? So 4 columns were A, B, C, and D. Then what is happening after transformation? So what are the second degree polynomials that can be obtained from there? So one thing can be obtained is 1, and again, as I was telling, A, B, C, D, A square, B square, C square, D square, and AB, BC, the multiplication of the first 2 features. So maybe sepal length, sepal width, multiplication of sepal width, petal length, petal length, petal width, sepal length, petal width, and so on. Sepal width, petal length. So so like that, there will be 15 features after the transformation. Okay, and then after transformation, we are printing the shape of the transformed matrix. Okay.
Okay, sir. Thank you so much.
Yeah. And then someone was telling about the, we were asked to make the Seaborn plot. Sorry, so the correlation plot, basically scatter matrix. So this is pretty simple thing. Obviously, we have the load the data set, iris data set, and then we are just putting in a grid, and we are mapping the with SNS.scatter. Okay. So how is it going? We have sepal length, and this is the y-axis. So sepal length, sepal width, petal length, petal width. So this is the sepal length. So obviously sepal length and sepal length itself has a linear relation. So that is of no use. And here also, so all the diagonals in here in this matrix. So sepal length, then sepal width. Here also in the second row, second graph, right? So here also both y-axis and x-axis are sepal length, sepal width, sepal width. Here also it is the same petal length, petal width. So these are linear. Other graphs are actually showing a two separate blobs or regions, right? So here is one region, another two distinct regions are mostly available. You see, so sepal length and petal length. If you plot them in y-axis sepal length, then in y-axis petal length, then you see there are two different blobs, right? So those kind of insight we can generate from.
Sir, can you give the argument hue just to see like
where?
Yeah, in that plot.
Okay, scatter plot, then comma hue. Is it? I don't know the plot.
Yeah, like
this.
Yeah, because see, for x and y, like there are two guys, right? So it will plot them in a different color. Hue equal to like
tell me.
Yeah, equal to y or something like that feature.
Hue equals to, okay, let me check. Maybe SNS to. Here it will not be available, I guess.
No, say for example, normal scatter plot, like whenever you do that scatter plot, right? So if there are two different kinds of data, then you can give that hue equal to that particular variable name, whatever is holding like two different unique values, right? So then it will like plot them in a different color.
But we are plotting the correlation between two different features, no? Hue equals to column name. Okay. Dataset.
Yeah, if you see these things, like everywhere, like they have given the hue value.
Okay. Hue equals to species. Okay. Let me put, I have not put, let me put, so maybe I can put a simple length. Not sure.
It should be a variable actually.
Sorry?
It should be some variable probably.
This is what you are talking, no? Hue equals to then inside double inverted comma.
Yeah, here you specifically know that, but in that grid plot, scatter plot, it is coming like x, things are changing, right?
Okay.
So
Yeah. So for every case.
Yeah.
Okay, let me see whether for one variable it works. Okay, no. Put or interpret the values.
Just put this. Take the data.
Sorry.
Target you put that the target value you put. U equals to. There you are getting this target list value, and you just pass that series.
Correct, that y.
He declare any y here.
Okay, u equals to.
Or you put your data. Take the last column. What is your column name?
Level.
Level. Yeah.
Okay.
Data dot level. No inverted comma. Just put directly value.
Yeah.
A dot. I think its variable is your A dot level. Yeah. A dot level.
Yeah.
Yeah. That's it. It will work.
No. Okay, let me check then. Let me get back.
Target names. Can you please put target names?
Let me get back to you because I will lose time then. Okay.
Yeah, it's working. You can try like this.
Yeah, sure.
It's coming. Data dot target. I don't know what.
Yeah, but okay. So basically, we okay. Someone has actually plotted it here. Let us see. SNS dot pair grade iris. Okay. Iris.
Your data is in Panda data frame, right?
Yeah. It's a Panda data frame.
Then it will work. For me, it's different color.
Sir, can you please put hue is equal to data dot target. Data A dot target. It will work, sir.
No, but his name is level, not target. He is putting A dot level.
No, sir, comma. That is what is giving a problem.
Oh, sorry. You are passing as a string value. You need to take the raw data and that value 0, 1, 2. Can you go to
I'll get.
Yeah. Okay.
Yeah. Tell me what are you telling?
You have to go to the actual data. Can you go up a little bit?
Yeah.
It's a column. This is a column. Go up. Where you? This is the A column. Can you just put A? Only the A. What it is showing A?
Here?
Yeah.
Q equals to A?
No, just display the A.
Okay.
What is there in the A means what column you need to.
A is the full data set.
Then what is the last that label column name? It's just print A dot head in up one cell.
Sir, create one like code
Yeah,
block.
right.
Just
Just
see
put A
what
dot
is
head.
Or type A.
Yeah, it's a label. No,
A
you
dot
have
label.
to. The value we need to convert it to pattern.
So this is not happening because we have used pair grid. If we have used directly the scatter plot, then this would have been possible. But here we have used pair grid, which is passing in list to the parameter SNS dot scatter plot. That's why this is not happening.
Okay. Okay.
Pair grid also will work. It's
Yeah,
working
actually,
for
I have the solution with me right now. I can see different colors.
Okay,
no,
sure.
This your
Let's
label
share
has
the
a
code.
different string value.
Sure, you can share the code in the chat box. Yeah.
Okay.
No issue. Yeah. Okay, let us go back to the next question then maybe. Think. Yeah, so the thing is we have to import, this is on one hot encoder. You have to import it from SKLearn.preprocessing and just print the shapes after. So this is basically on the I think on the iris dataset only. Yeah. So on the iris dataset only, you can import the one hot encoder and you print the shapes of the matrix before and after one hot encoding and print the 45th to 55th row of the matrix after the one hot encoding. Okay. On the iris dataset. So basically there will be a change from 1110 from the column values between 0 and column, obviously.
Sir, the iris dataset like all are numerical values, right? Like using one hot encoder, it will be like then it will be huge number of
Label
columns.
has label has
Label we need to apply on the label. Not
Yeah,
all.
sorry. Yeah. Please go on. Please go on. Yeah. Tell me. Hello. Yeah, someone was telling something.
Yeah, sir. You want to apply on that data or on that level only?
On the level. Yeah.
On the
So,
level.
but
Yes.
yeah, on the level. So basically, this is the yeah. Okay. Let's just wait for a few minutes. So we'll send. So if all the questions are not solved by within this time, we will anyway give you the PDF. Okay, of the solve with instructor. Okay, so just practice it, huh? When you're free or something. As sir was telling today. So what is the deadline for week 2? Can anyone tell? I mean, just on the top of my head.
Sir, 9th.
Week 2 is also 9th, is it? Week 1 is 9th and
No, sir. Both the weeks are 9th.
okay. And today, week 3, we will revise.
Sir, you will be uploading them in the supplementary section, right?
Hi, sorry, I got disconnected. Maybe due to this construction. Yeah, so we will discuss, but before that, someone was asking about the PCA code today, na, to sir. Is that person here who was asking the PCA code?
Yes. I think you have replied to my discourse forum.
Yeah.
So,
okay, so you have the code, na?
Yeah, you have given that, so I'll go through and try that in my collab.
Yeah. I actually saw that. I mean, in the video, it was the show code thing was there, and then it was not maximized. Yeah.
Yes.
So, yeah, just let us know in the discourse or wherever. we will see.
Sure. And today's solve with us instructor session, you'll be uploading them in the supplementary section, right?
I mean, yeah, I think so. I mean, till now it is not uploaded. So yeah, I think in supplementary only it will go.
Okay.
Let's see. Okay, let it get uploaded, then we can tell you. I mean, whether where it is getting.
Yeah.
So anyway, so as we were talking about one hot encoder, so one hot encoder creates a feature, and as we know, for each of these cases, each of the matrix values, it is matrix elements, it is creating one particular column, right? So like here,
Sir,
Punjab.
if you are sharing the score, we can't see. Sharing the screen, we can't see.
What are you seeing? Oh, sorry. Yeah, I mean, I got disconnected. Yeah, so I was sharing about this. So what are we doing is that we have the new feature and the old. So basically, so for Punjab, we have three values here, three features here: Punjab, Rajasthan, and Haryana. So so therefore we are having three columns for three values. So the first row is Punjab. Therefore, the first column is Punjab. Rajasthan is in the second row, therefore a new feature is not in the first row, therefore 0 in the first row, not in the third row, but in the second row. So therefore in Rajasthan is there in the second row, second column. Haryana is not in the first row, not in the second row, but in the third row. Therefore Haryana is there in the third row, third column. And how do we implement one hot encoder? We import it from SKLearn.preprocessing. Now, how do we go through? Let us go through this. So, from SKLearn.preprocessing, yeah, we have imported ordinal encoder also. So, one hot encoder we import, and what is the shape of the matrix before encoding? So that was 150 values are there, and then what we do is we apply one hot encoder dot fit underscore transform, and we reshape it within -1 to 1. So and what is happening after encoding? We are printing on labels. So from 45th row, 45th row to 55th row, you can see that for some cases of the labels, it will be like the first column is 1 1 1 1 1. So basically the first feature is present, and for some of the cases the second feature is present. So basically this is the kind of thing which may happen in the matrix. Okay. Yeah. And another question that we had was about importing the California housing dataset. So where we're asking to select the features according to the top 10 percentile and then print the shape of the feature matrix. So how we would do that is that we would import the NumPy as usual, import the California housing trend test split, the mutual info regression, all these things we will import. And then once we download the data, we select a subpart of it. So maybe the first 1,000 rows, the last 1,000 rows or something. Then what we do is we select the top 10 percentile, right? And what is the shape of the feature matrix that we print? So at first it was 8 features are there, 8 was the value, and then once we take the top 10 percentile, then it becomes the only one column is there. So one feature is there. Okay. So what is the shape of the feature matrix after feature selection? That comes like 1 only. So these small applications of the topics or of the functions or transformers that are taught, those will be shown here, and those will be given. Similarly, we will have the pipeline as well. So we have to generate a numeric pipeline, a column transformer, using a with a pass-through block, then a simple imputer, and a standard scalar operator. Okay, and the names of those things are also defined. Then what are we doing is we are generating a categorical pipeline, and so we are actually generating a separate pipeline. And then so one is a numeric pipeline and another is a categorical pipeline which we are making. Okay, so and we are adding or combining these two pipelines using feature union, and we will display. So how do we do that? We generate the pipeline. So we will give you the codes, obviously. Just go through the codes once, and maybe the columns may the comments also may help. Okay, and how do you display the pipeline? So you are displaying it using the HTML representation here. So we will get the full pipeline shown here. And obviously we can ask for different steps of the pipeline, how to access the different steps, or how to write the fifth step of the pipeline. Oh, okay, something like that. So you have the standard scalar, which is also known as standard scalar, then simple imputer with a median strategy. Okay, and this is a pass-through block. So we, as we were talking, we have two pipelines, one numerical and one categorical. Then we are doing the feature union of them, and we are just making the union of numerical and categorical.
Sir, can you please go to task 4 for a minute? Okay, no, continue please.
Yeah, sure, no issue. Yeah, we are.
Yeah, just there only. Sir, I'm not able to. Okay, we have to do first 2 array, then only it will print over.
Yeah.
Okay.
Yeah.
So what does reshape do?
So reshape basically, I think it shapes it within that particular value range. Okay, so from -1 to 1 only, it will shape the values. So if there are
just taking the last column.
Yeah, for the last column only. So if we have more than, say, what I think is happening is that it is just keeping the range fixed. So the range is -1 to 1. So here what we have seen is that it is giving from only 1 and 0 here, right? So either positive or negative or some kind of that, only 2 values.
Excuse me, sir?
Yeah.
The reshape is not doing the checking like -1 to 1. What it does is,
okay,
a.label.values is an array with all the elements. But now, so when we need to pass the argument of a transformer, it takes some column, so it will transform the array into a column with 1 in each row. So it just transforms the array.
Can you please repeat? I was sorry, I could not hear. Can anyone understood? I mean, what did he say? He just broke.
No, his voice is breaking.
Yeah, sir. Basically, what it does in this reshape, you are giving two values, -1 and 1. Okay. The 1 is basically the number of columns that you want to create. That like in each row, how many numbers will be there? That is 1. Okay. And -1 is like remaining things you adjust in -1. That means, say for example, if you have an array of 10, size 10, okay, so you can create np.1's your size 10. Okay, now you want like it will create a 1 row and 10 columns, right? Now you want to create reshape this array into a like a 10 cross 1. So your np.1s will give you a 1 cross 10, right?
Okay.
And now
but how is -1?
Yeah, -1 is like like if you do not know how many rows will be there. Okay, you are saying my column requirement is 1.
Okay.
So that you are specifying, and -1 will take the remaining part. So
what
that
do you mean
means
the remaining part?
Okay, can you write it np1's 10 like one array? Then it will be clear.
Okay, right now though I don't have. Okay.
Okay.
Okay, just can you just tell me? I'll look into it. Just
Sir, I would like to add a point. Like, sir, when we have printed shape of matrix before encoding, it's saying 150 comma nothing. But when we'll do the reshaping of this, like when we do the reshape and when we print the shape, it will say 150 comma 1. It's a difference of this thing. Like it's in 1D array and that is in 2D array. Difference is this 1D array and 2D array.
Okay, so okay. So if we are not putting the reshape, then it will give a 1D array, and if we are putting, then it will give a 2D array. Is that what you are telling?
So it is not only, it is one way you can think about that, but otherwise, like you can say, for example, you have 10 numbers, right? You want to create a 5 cross 2 matrix out of it. So you need to use this reshape. Okay, 5 cross 2 means your 5 rows and 2 columns. So your right side value will be 2, and left side you keep it -1. It will take as 5.
Okay, so you are telling the lower limit.
So it will get cleared when we will print. Just let's write 2 commands: print a.label.values and print a.label.values.reshape. There will be the display will itself clear what is the difference between doing shape.
No. See, when we are putting -1, it is actually flattening the array. So if you see here 1 0 0 0, it will make a single line, and after that, what you are putting 1 row, then it will show in 1 column. So -1 is for
no, we are getting 1 0 0 after transforming that array into fit transform. Like we are doing multiple things here. We are taking this array of 150 comma 1, and when we are it to fit transform, then we are getting 150 comma 3. But when a.label.values.reshape, this is an array of 150 comma 1. It's in 2D array. Whereas we have to pass 2D array to the fit transform. This is the main objective of doing this.
Right, that's correct. You cannot pass 150
1D array.
Yeah, it should be converting to 1D. So -1 is flattening, then it is making to 1D array. Without flattening, you cannot make it to 1D array. That's why they're putting -1.
Okay, thank you everyone. So we will sure, I will also look into this. Thanks for whoever contributed. That is very helpful.
Sir,
actually.
I have one question. Can you go to the task 7 regarding this future?
Yeah, we will actually give you everything. Okay.
No, I have just one doubt.
So
when we are not go up the test 6 and not 7.6. So when putting this feature union, can you little bit come? Feature union. So we are getting this pipeline. So in this pipeline, we can apply the fit and transport method, right? Because when I'm trying to put this fit and transport, I'm getting some error. I'm unable to understand why it is not working. So is there any restriction for the pipeline? It is working
on this full pipeline.
Yeah, for pipeline it's working, but for feature union, it is not working. That fit method.
No, I mean, what if you just define this as full pipeline equals to in 1 column? I mean, what you are telling is you are applying the second command at the same time as feature union, right?
Yes. What the my data
so
like if, so this number pipeline and this categorical pipelines are different, but when I'm checking the shape, both are showing same shape. Okay, I will put in discourse if you have time. Then
just so my suggestion is, I mean, what is happening if when you are like applying the fit transform on the full pipeline?
It's throwing the error. It is telling that the shape is not correct.
Then also it is throwing the error.
Yeah. But I will put the pipeline 1 by 1, then there is no problem. Maybe I doing something.
Okay.
Some mistake is
but so after the fit transform, you have to apply feature union. That's what is happening, is it?
Okay, maybe let me try.
Yeah, just post in the discourse. We'll see. Okay.
We'll try. Thank you.
Sure. So I'll will release the I'm going to release the thing the week 3 today, and the solve with us also will go in the. We'll try to put in the portal. Okay. Okay. Thank you guys who joined. We'll close the session here, and next is on I think Wednesday. Next Wednesday, we'll come back with the week 3. Okay.
Yeah. Thank you, sir.
Yeah. Sure. Thank you. Thanks for contributing. We have contributed. It's a very good. Thanks.
Thank you.
One comment, I have a problem visualizing, so I definitely am getting very confused with these arrays and vectors. So I would have to read more on it.
Okay. Oh, okay. That was the okay. Yeah, sure. Okay. Well, yeah. Thanks everyone. We'll close the session. Thank you.